Hey everybody, this is Larry. This is me going with Q3 of the bi-weekly contest 56 some game. So I actually did not solve this during the contest, though a lot of it's because I spent too long on Q4. I actually got this near the end after I kind of skipped to Q4, and then I came back and then I would refresh mine, and with that mine I was like, oh yeah, there's this observation that you have to make, and that's what I did. Hit the like button, hit the subscribe button, join me on Discord, give me some support, give me some love. And if you like discussing these problems right after the contest, join me on Discord because that's what we do. So this one, it's a game theory problem. To be honest, I think if you do not have the game theory background, it's going to be very tricky. Maybe you could guess the solution or ideas, but it's still a very tricky problem. And I solved this actually a couple minutes after the contest, it is what it is. Like I said, mistakes were made. But the idea here is you have to kind of think about, okay, let's reduce there's a couple of observations to make. Let's reduce this problem as much as we can, right? So number one observation is that, okay, if there are question marks on both sides, and Bob wants to keep it the same, it doesn't change the answer because... And what I mean is that you can remove the question marks on both sides, because if it is already the same, then Bob can just choose the same number that you choose, right? So if you choose X, then Bob will choose on the other side X as well. So they cancel each other out in that way, because Bob wants to keep it the same. And so then the second part is that, okay, so you have question marks and a number that a target number that you're trying to reach, right? And here, of course, if it's depending on how you want to count it, but there is an impossible situation where basically, if you cannot get to that number, then it's true, just because, for example, I think this is on example 2, which is that here you're trying to get to 7. If you just go to 9, then you're making it possible. Also, if you have the other case where if you have a question mark on the left, so it's not going to be possible. For example, if there are numbers on both sides and you already have a bigger number on the side of the question marks, then it's not going to be possible because you already have bigger number than the other side, so you can't make it true, right? One more observation is that, and I keep mixing this up. One more thing is keeping in mind that if the number of question mark is odd after you remove them from both sides, though you can only remove even numbers anyway. So if the number of question marks is odd, then Alice always wins, because if you have the last move, you're not going to change it so that it's the same, and so you have to choose literally any number that isn't the one that gets you to lose, and you win, right? So that's basically what I have here. And then the rest depends on this idea of a NIMS game. And a NIMS game is that you could choose any number from 0 to 9. And you can the reason why I had a lot of issues during the contest with this one was that I was off by 1 because I forgot about the 0. So I was just choosing between 1 to 9. So I was subtracting 10 for whatever reason. And we can look at some of my wrong solutions. Hang on. But yeah, but if you were to Google, I would look up NIMS game or Nimbers. I know it looks like a typo, but it is not a typo. But basically the idea is that because you can choose between every number from 0 to 9, you can think about the safe states, right? In terms of the states, that because Bob goes second, if we are able to get back to a safe state, and if quote unquote a winnable state on Bob, if Bob is able to be on a winnable state and you're in that state, then Bob can get it to the next winnable state. And it turns out that for every round, which is 2 times the number of turns, if you're on a multiple of 9, you can always get to the previous number of 9. So you can kind of look at this deductively or inductively, where, okay, if there's 0 turns left, you want the sum to be 0, right? That means that if there are 2 turns left, Bob wants the number to be 9. Because, why? Because if it is on any number, let's say 10, or maybe a smaller number, let's say 8, well, if it's 8 or smaller, you just choose 9 and it's not going to be even. If it's 10 or more, you could just choose this to be, you can choose this to be, say, 2, and then you have 8, and then Bob goes, oh, wait. No. If it's 10 or higher, you choose the number 0, and then Bob cannot win, because if Bob just chooses 9, you cannot win, right? So the only number that Bob can win is 9, and if it is at 9, you could choose any number, and then Bob wins, right? So that's basically the idea, and these are, I believe, called winnable states for Bob. And once you get that, you can kind of inductively choose, okay, if there are 4 turns left, it's 18, and so forth, ... And the rest is basically just an implementation of this. I wrote a lot of useless code, to be frank, but that's basically the idea, is that, okay, I mean, the count delta is the number of turns, basically the number of question marks, and of course you can just choose this as this divided by 2, but then of course I just multiply 2 on the other side, and that's basically the idea. I should have been able to solve this during the contest, but if you look at me solve it live, you'll also see that I actually confused it with, because I thought that, for whatever reason, I thought that the lowest number is 1, so then I had 10 on both sides, but as I came toward the end, I was able to come toward this, but I just ran out of time, to be honest, because I solved Q4 with 5 minutes left, and I wasn't able to solve this quite well. This is my last attempt before I AC'd. I was able to AC right after the contest, but yeah, I had some while loop, and I think if I had this equals to 9, then I would have been able to be right, with if I changed some other things, because I think I submit this with like 20 seconds left or something, so it looks very awkward, right? But yeah, so what's the complexity here? Well, it's going to be linear time, because you have to go through the array or you have to go through the string to kind of do all these counting, but after that, it is just O of 1. That's all I have for this one. Let me know what you think. Hit the like button, hit the subscribe button, join me on Discord, watch me solve it live during the contest, and then after the contest, next. Okay, so Bob is trying to get them to be equal, and Alice is trying to get them not to be equal. That's really weird. Okay, it's judging. Oh man, yeah, well, okay, fine. Silly mistakes again. I knew that one, but oh man, wow. Larry, this is going to be rough. 2 penalties already on silliness. Okay. Some of the digits in it can return true if Alice wins. Seems like a hard one, to be honest, but that's gonna be hard. If only I didn't make silly mistakes on in this contest. Okay. know how to do this one. I wish I got the other two without silly mistakes. Then it would have been probably 2 problems. Would have been a good score. How do I even phrase this? Bob always wins. This is a hard problem, actually. Okay, so the first thing is that the 2 question marks, they cancel each other out. So then it's just 5, 9. Then it's just, is it possible to do one side more than the other? Something like that? Maybe that sounds right. Okay. I don't know why they don't just give us 2 strings though. It's a little bit weird, but maybe that's fine. Okay. I was thinking about writing a helper function, but it's fine. Okay. Is it always possible? Let's see. It did the same. Then we return whether the sum is the same. Is that true? Yeah, opposite of it. Because if they're the same, then Bob will just do your move. That's not true. Well, and if the sum is different, what happens? Let me think about this. If they're the same and the sum is the same, I just type it out, then return true because Bob can always move it. Otherwise, can Bob make it the same? Oh, Alice has to make it not equal. Okay, whoops. So if they're the same, then Alice, then Bob always wins because Bob will just keep it the same. Okay. Otherwise, how many people have gotten this? This is a pretty hard one. Only 3 people gotten it so far. Eric though, of course. I am very sloppy. Bob is trying to keep it the same. But we can actually just subtract them because if it helps, Bob will just, because for Alice, it makes sense for it to just choose whatever number, so then you get the delta, right? And you always get 5s. So I keep forgetting my One's not the same. So if the sum is equal, then this is false because Bob can always do it. Otherwise, for every number that you do, no, then it's just return true because they cannot match you because you just choose the side for which, yeah, because you just choose the side in which it is lower and then you just, or higher, and then you just choose a 9 and then they can't really match. Okay, I believe in that then. Count left is some right. Okay, so now count has more than right. So then what happens? If you have more on the count side, then and then basically for count or for, I think you could do this with actual math, but I am trying to figure out right now whether because I'm a little bit dumb and it doesn't really matter. So for each different number, because Bob will always just match you. So for here, whatever you do, there's a 5 different delta for every one. Okay. How do I phrase that? So that's 10 for 2 numbers? Okay. This is so hard. I'm so bad. Okay. And there's a mosquito flying around. Maybe just a little fly, but still annoying. No, that's not it. They say they could catch up 5 at a time for every 2 numbers. And it doesn't really matter what you do. Okay. And then if count, if sum delta is greater than 0, return true, you win. Otherwise, return false, something like that. I don't know if this is right. I have to figure it out. False, false, false seems a little bit wrong. It's basically okay. There's 2 numbers. Delta is 7. Maybe this thing is wrong actually. Okay, so the directions matter. I was thinking that it doesn't, but how do I don't do this? Maybe I optimized a little bit too early. Okay, fine. Let's do it the other way. Okay, and then now we can do the thing of count delta is equal to this thing, and then sum delta is the absolute value of this. Okay. And then now we can do something with the signs. If sum delta is negative, so if this is negative, what happens? That means that we can go over because it's our turn. Okay, I mean it's good that we have one more thing, but so now we have 2. Okay, so we have 2 extra on the right side, negative 9 on the left, or plus 9 on the left. So 2 of these cancels out, so I have this essentially. Let's subtract this, so then I have 9 and 2 question marks. So whatever I do, the other person will get it. How do I simulate that. If some delta, so okay, if count delta is equal to, so now it could be either 2, 1, or 0. No, it could only be it can only be 2 or 1. So if this is 2 and it's our turn, then what happens if it is between, is that right? Did I mess up the math? Because basically if I go cancel, but then I could just choose 9, right? Maybe my math is wrong, or my assumption is wrong. Basically, if the 2 numbers left, I can choose any number. They could choose be 0. Okay, so if it's 9, it's we are good. Is it only if it's 9? Because if it's 8, then we choose 9 and we're over. I think that's the problem. If it's 10, we can choose 0 and it's over. So it's only if it's 9, huh? If some delta is equal to 9, return true, return false. If there's one number left, we're done. So if there's only one number left, we can always choose a number. So okay, so we return true here as well. Is that true? That's such an awkward thing. Well, would be better if this was actually right though, but So okay, so false, true, false. I mean, I have false on the last one, but why is this true? So okay, so we have 2 left, and the answer is -7. So this should be. Oh, I mixed it up again. If it's 9, then we cannot win. Otherwise, we win. Otherwise, if there's 1 digit, we win again. Okay, well. How is this working again? Come on. Did I get the signs wrong? Is it -9? Okay, so it's -9. I don't know if this is right, but I'm spending a lot of time, so I hope I get one. Ooh. I was hoping to get an answer to kind of help me figure it out. I was hoping to get a shorter answer, to be honest, as well, but okay. I am very bad today. So I returned true too early. Did I? Oh, I mixed up the signs here. So, okay, is that true? Okay, because we have 12 numbers left with 54. I don't know if this is necessary. Is this necessary? Let's try again. Wait, did I not? This is the same case, so I'm just being sloppy as well. But we expect it to be false. Okay. Why do we expect this to be false? I am really bad today, friends. Oh, whoops. I got all my signs wrong, essentially, basically, to be honest. But Okay, so we have 5 of these, so it goes to -4. I wouldn't. So basically, did anyone skip ahead enough? Well, Yui did Q4 really quickly, so this is not looking good for me. A lot of people did Q4 first, so maybe I should have done that way. But okay. Two numbers left, -1. So it is definitely true that you would win, but according to this, you're not supposed to. And I gave 2 wrong answers because I'm dumb. But wouldn't you just do 9 1 9 1 9 1? You have 12 numbers on the left or the right, whatever, and you have 54 numbers to make up, right? So you do 1, and then the other person will do 9, right? Trying to catch up. Oh, but then on the last one, you may not do 9. You try to get it to 5. So, okay. So we have 4 left. We have 4 is 14. So then, what does that mean? Well, we have 4 numbers left. Then, what are the possibilities? If we have 4 numbers left, then I will do a 9. If I'm Alice, I do a 9. 14, we go 9, so then, and then we have 5. And then we're already not possible, right? So, oh no, because if I do a 9, then no, I don't get it. Did I misdo the math? If there's 4 numbers left and it is 14, what happens? Oh, maybe I'm too aggressive on the, because it is true that 14 is not good, but you would not go to 14 because it would be more earlier recursively. Huh. Okay, let's skip ahead. Painful, but I thought it didn't matter. That's why I didn't do it that way. But this one, I think this is close, but I agree it is not. Basically, you want to get to 9 here. Are you able to do it? That's what Bob is trying to do, right? And the question is, how do I do it? I mean, you have to do it recursively, right? So if 2 is -9, can we get to -9 to whatever, right? If count delta is odd, then we return false. We return true because we always do it. Otherwise, this is even, right? Even, then it means that whatever we do, they're going to just do 9 until, okay. This is false because I don't think this is right, but yeah, I didn't think it was right. I just YOLO because there's a minute left. But so that was definitely YOLO. It's something weird like this though. Basically it's just game theory of, okay, so there's 9 is a stable point, and then okay, I gotta stop doing it. Basically, their first thing is, and can we get to 9, right? If some anyway. I think this is close. To be honest, I feel like this is close, but it is not quite. Alright. Whew. Okay. I'm gonna set up streaming this live. I mean, I don't know. I should have gotten Q4 much faster. I was dumb on I was stubborn on it. This was a tough contest. I don't know how to do Q3 because it's one of those game theory ones. What the hey? But that's basically what I was trying to do. But I think I messed up a few things. I think I was close. I was pretty close, but okay. That's all I have. Stay good, stay cool. Thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Thanks for your support, and I will see you next contest. Bye bye. Actually, I'm gonna finish doing this first because, yeah, because I was close, but I spent too long on Q4, so I didn't have time to come back to it. I think I got to the point where, yeah, like we look at error though. That's the idea. Yeah, I mean, I had something like that, but I wasn't able to do it. Yeah. Oh, I think if this was 9, maybe this is right. I think I wasn't. Okay, maybe not. There's still quite a few things wrong, but. Maybe something like that. I think I mixed up the signs, but the idea there is that it gets back to a stable point. Yeah, I got it right after the contest. Yeah, thanks for watching. Thanks for the support. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this contest and this problem and this explanation. I will see you later. Stay good, stay healthy, stay cool, and to good mental health. Bye bye.